We're going to take a look at factoring complex trinomials. We're going to use a method called decomposition. And so this method here will allow us to break these down into components that we can factor by grouping and solve the equation. So given the two pieces here at the either end, we're going to multiply these together. So I usually draw a bar across the top and do -20 times 6, and that's going to get me -120. So step 1, multiply the first and last coefficients. From there, what we're going to do is find the two numbers that add to -7 and multiply to -120. So this is similar to the other method. So we're two numbers that add to the middle and multiply to the top. So we have -120 on top, -7 on the bottom. We need to find two numbers that are going to multiply to -120 but also add to -7. And so if we look at pairs, you got 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 7, 8 and 15. So 8 and 15, if I look at those two and I have +8 and -15, +8 and -15, that's going to add to -7. It's also going to multiply to -120. So I found my pair of numbers. So I'm just going to clear this off. So step 3 then is to rewrite the middle term with the two numbers you found. So I got +8 and -15, so I'm going to rewrite this middle term here. 6x squared plus 8x minus 15x minus 20. So I've taken that -7x and I've rewritten it into plus 8x squared minus 15x. And so just clear that out of the way. So the next step we're going to factor by grouping. If we look at this first pair, and if we've set this up correctly and it's factorable, then in that first pair, we'll find a common factor. In this case, it's 2x. So this is just the first pair. So the common factor 2x, we have 3x plus 4 remaining. Now, we always bring down this sign here. So this minus sign comes down as the number we pull out right here. So we're going to factor a negative number. If it was a positive there, we would bring down the positive. Common factor here is 5, so it's -5 as our common factor. And we factor that, we get 3x plus 4. Negative 15 divided by negative 5 is positive 3. Negative 20 divided by negative 5 is positive 4. If you've done everything right, you should find that these two brackets have the same values in them. And then for our last step, we're going to factor out those matching brackets. So we factor out 3x plus 4, and then we're left with 2x minus 5. So to go over that again, we multiply our first and last terms together every time. It should be an x squared, x, no x format. So multiply the first and last coefficients. It's convenient to put it on top like that. And then we have negative 120 and the negative 7. We're finding two numbers that multiply to the negative 120, add to the negative 7. We found that they were positive 8 and negative 15. So we rewrote that middle term. We rewrote 7x with the plus 8x and the minus 15x. It doesn't matter which order you put these in. If you put them in the opposite order, what will happen is you'll just get the answer in the opposite order, but it'll still be the same two terms. Once we've written that out, we factor the first pair using the sign that is connected to the next term. In this case it was negative. We factor out the second pair, and then as our last step we factor out that matching bracket and get our final answer. Why this works this way? Well, if we were to actually FOIL this out and expand that out, which we could do as a check to see if we did it right, we should get the original question. So if we multiply that out, first times first is 6x squared. First times last minus 15x. Then the 4 times the 2x, which is the middle terms or the inside terms, plus 8x. And then the last two terms there, 4 and negative 5. If we take a look here, other than these are in the opposite order, but still the same numbers, this is what we're doing, is we're recreating this scenario in reverse with that method. And then if we simplify that down, 6x squared minus 7x minus 20, that's the same as above, and thus we've done the right thing. This is also a way to check any of your factoring. When you factor, if you expand it back out, you should get back to the original value.